GM, welcome to a new episode of Protocol Explorer. So today I have the infamous, famous, most popular person I ever knew. This is all based on like an interaction we had in Paris. So if you were there, you know what we're talking about. But um, this is Idris from Axelar. Idris, can you tell us a little bit about yourself, what you do, um, and yeah, anything else you want to add on?
Everything.
Everything, just
Yeah.
your entire life story, all of it.
Yeah. Thank you so much. Thank you so much, Rahat. And so, hi everyone. My name is Idris Olubisi. I am a software engineer and a technical writer. I currently work as a developer advocate at Interrupts Lab, working on Axelar. And I am also the founder of Web3 Africa, a community focused on, connecting the dots within the Web3 ecosystem, specifically for African ecosystem, and also helping to onboard, support, and educate Web3 builders. I also volunteer, like I do quite a lot of volunteering for like between doing community activities, doing helping developers succeed, trying as much as possible to give back to the community. So you can call me like a community person, like a community builder or a community leader, anything you want to call it, right? Yeah, and I'm really excited to be here, where we get to talk about everything cross-chain, exploring cross-chain use cases. Why do we even need it in the first place? And also, open to your questions. Of course, be happy to answer all of them.
Yes. So for folks who are tuning in now and watching, drop some comments in the chat. Let us know you're here. Drop some GMs. And as we're kind of going through, you know, the um, the overall presentation, if you have questions, please drop them. We will make sure to address any of them. I know a lot of this might be new stuff for folks, or it might be stuff that you want to get clarification on. You have an awesome resource here right now live. So, yeah, Idris, I will
Yes.
share your screen and then we can go from there.
Yeah, let's go. Let's
Cool.
go. Yep, yep, yep. All right. So I believe you all can see my screen now. So yeah, we'll be talking about exploring cross-chain platform with Axela, and also there'll be a cool part where we have like a demo session to kind of bring all of these things we'll talk about during the presentation to live. Don't worry, I've also prepared this project. I've prepared a project that you can clone later on to code along, or like look how the implementation is done, both on the contract side and also from the front end. So let's get right into it. Yeah, like I mentioned earlier, my name is Idris Oluwisi. I work as a developer advocate at Axelar, and you can also find me at all on all platforms at Olanesoft. Until recently, my account had issues on X, and then now I am using underscore Olanesoft. But any other platform is Olanesoft. Yeah, so today it's kind of a talk plus a workshop, but then basically we are going to look into like the brief history of blockchain, how everything started, and then when the world started thinking about the cross-chain ecosystem, and also exploring the Axelar stack, like the tech stack, looking at how things happen under the hood. What are some of these things? How is Axelar doing this cross-chain communication between two different protocols, and then doing it in a decentralized manner? And also, we'll talk about general message passing, and of course, the demo where we get to showcase like these things in action. Um, yeah, so in the beginning, right? I know it's not in news, you might have heard it already somewhere. When cryptocurrency, when Bitcoin first launched in 2009, and it was introduced by the anonymous Satoshi Nakamoto, where it utilizes a decentralized blockchain network and a proof of work consensus mechanism. So in this era between 2009 and 2017, we had like tons of blockchains like Bitcoin, we have um, Maker, we have Compound, we have OX, we have Ethereum. But then in 2014, Vitalik proposed, Ethereum, which introduces smart contracts to enable decentralized application on blockchain. So initially, the Bitcoin what Bitcoin did was to solve the problem of payments, and now Vitalik took a step ahead, like a step further, to introduce smart contract development that would enable blockchain application being built leveraging that will enable decentralized application being built on the blockchain. So we have like permission, private and permission blockchain gaining traction as organizations start to explore more of these use cases during this era in maybe healthcare, supply chain ecosystem, voting system, and many more industries, right? So, but it didn't stop here. Of course, this is between 2009 and 2017. But as things evolve, as things move on, the cryptocurrency market saw a precedent boom and a subsequent correction from like late 2017 to 2018. We began to see like government and regulatories around the world developing a framework to govern like cryptocurrency and ICOs with mix of approaches, some supportive and also some others very restrictive. We also began to see like the enterprise blockchain adoption grew grew really as high as having major companies explore solution across different industries like the finance ecosystem, the healthcare ecosystem, and some other industries. So during this period, where we tend to see layer two solutions solving the existing problem. So research during this era was focused more on improving blockchain scalability, interoperability, privacy through like layer two solutions and Lightning and side chains. And we also see the likes of CBDCs like stablecoins and central bank digital currency emerge to address volatility and integrate digital assets into the mainstream finance. So all of these things are like things that we identify as a problem, and then everybody within the ecosystem, start to think about how to solve this problem with scalability. And we also see a lot of increased scrutiny, highlighting the need for better security, consumer protection amidst different acts and scams, things like that, and also enforcement actions. So, like as you can see on the screen, like we have like tons of layer two solutions that people start that were solving or are looking to solve that particular problem, right? So interoperability solution within the Cosmos ecosystem start to gain tons of traction, and also the Polkadot ecosystem. But then decentralized finance based on blockchain and smart contract exploded between 2019 to 2020, where we start to see more decentralized finance based application, which is of course built on the blockchain. But did all of these things end here? Now that we've seen solutions that are looking to like scale, to help scale what we currently have. But then think about this, where we began to see more and more and more protocols. But how do we scale when we get to add even more protocols with capabilities and features? How do we make this process also seamless for new developers or enthusiasts? Because that's another thing we need to think about. Like not just people that are already within the ecosystem that already understand the system, but also how can we contribute significantly into the adoption rate of Web3 generally. Of course, we know our users have different needs, right? Some really cares about privacy, cost, and then they don't really care much about security. And then we have seen in cases where like users care much more about cost and security, and privacy is not a big deal. So all of these different needs, how do we cater for them? We're going to see more and more, as you can see on my screen, where we have Serum, Mirror, Uniswap, a lot of application, a lot of protocol, every dApp with different use cases means that more, it just means that the more we have like more chains, then we have more dApps, right? More decentralized application building on those chains. But then how do we have, what if I as a user or as a developer, let me say as a user right now, because like that's the end user. I don't really care about what chain I'm currently connected to. What I just want to do is I want to be able to send assets from this protocol to this protocol. And then once I land on your platform, I should be able to do that by just connecting my wallet. What is that thing that could connect all of this ecosystem together as the ecosystem, like as we begin to have like more blockchain within the ecosystem generally. What is that thing that will connect all of these blockchain protocols together in a decentralized manner, verifiable, seamless, and very simple? Another thing to think about is as a product or as a dApp builder, what if you could be where your users are, where connecting to a system that can bring you closer to where your users are on all of these protocols? What is that thing that could connect these protocols seamlessly in a decentralized manner, and then you'll be able to interact from one blockchain to the other? And that's Axelar. So Axelar helps to connect all of these protocols together. But then Axelar itself is a decentralized interoperability network that securely connects all of these different blockchain, allowing assets, application, and users on the various blockchain to seamlessly interact. So this solves the major pain point in blockchain adoption, the fragmentation across different chains. And because Axelar's trusted inter-blockchain communication protocol enables this cross-chain interoperability without compromising security or control, which means that you can be confident and also comfortable about leveraging the Axelar's API to connect with other blockchains. So the network, I mentioned Axelar is a decentralized interoperability network, right? The network is, blockchain agnostic and currently connects to major blockchains, Ethereum, Avalanche, all of these blockchain, by helping to bridge that siloed ecosystem that we had previously, and then accelerating like decentralized finance and broader adoption for blockchain technology. But to kind of keep it very simple, Axelar is security and decentralized focused. That's number one. It's currently integrated into 60 plus chains, which gives you access to all the ecosystem that you want to like extend your app capabilities on. And the cool part is it's very simple to use. Don't worry, you see all of these things in action, right? So Axelar, just to reiterate one more time, Axelar is a proof of stake blockchain network that is built on the Cosmos SDK that enables cross-chain communication between different blockchains. So it uses validator sets to securely process and validate this cross-chain because, of course, it's the protocol itself. So it has a set of validators to validate these cross-chain messages as, by collectively voting on their validity as you try to send messages from one protocol to another. So this message, of course, could also involve, sending assets, token transfers, and all of those things, right, between different blockchains. So let's take a look at what the tech stack looks like under the hood, right? Now you know what Axelar is all about, the problem it's solving, what is actually happening under the hood. So as you can see on the screen right now, we have like different layers where we have the application layer, we have the layer one gateways, and then we have the Axelar network layer. So the application layer is where we have like digitalized applications, dApp builders, where we have like different ecosystem, the Ethereum, the Avalanche, Cosmos, and also other ecosystem. And then in between that, with the layer one gateways, we have the APIs that interact with gateways. So for every ecosystem, we have like gateway deployed. So specifically, if it's EVM, then we have smart contract deployed. If it's non-EVM, it's an application deployed that interacts between your dApp through the Axelar API and the gateway. And then we have the Axelar network layer where consensus, where voting are being verified on chain, multi-party computation happen, and then validator, they have like set of validator that validates all of this interaction going from one chain to the other. So this is what the tech stack looks like under the hood when you leverage Axelar, how Axelar help process those messages from the source chain to the destination chain. Say you are sending a message from, let's say, any layer one, so like Ethereum to any layer two solutions, right? This is what the tech stack looks like from the Axelar standpoint. Now, let me talk about like some of the things that you have available if you want to leverage like the token transfer superpowers that Axelar offers out of the box. So we have three of them here. We have the deposit addresses, we have the send token, and then we have interchain token. So the first one, which is deposit address. So this is an example of how you can initiate a deposit address. But what exactly is deposit address? Deposit address is a simple, temporary special address that is created and monitored by Axelar Relay Service on behalf of the requester. So what does this mean? Maybe I want to send Rahat 5 ETH, and then Rahat, I want to send Rahat 5 ETH on probably on a different network, right?
I'll take
What I'm
5
just
ETH
going
on
to do.
any network.
Yeah, so if I want to send it 5 ETH on any network, what I'm going to do is to just generate the deposit address and then specify a few things here. The first one is the from chain where I'm sending it from. That's the source chain. It's Ethereum or like any source chain, right? But in this my example, I'm using Ethereum, right? And I want to send to any preferred network, like any network that I ever had preferred. I'm going to specify that destination chain. And also, I'm going to specify the destination chain address, which is the receiver address. That's the Rahat wallet address. And I'm also going to specify the asset that I want to transfer. So this SDK returns an address that can receive funds. So when you get that address, if that fund gets sent directly to that address, it automatically gets routed to Rahat addresses without you doing any additional step or like doing anything else. You might be wondering like, why do you need to generate a deposit address first before you be able to, send it to Rahat on any network? Why can't you go direct, right? These are use cases that are very important when you're trying to do things programmatically from the UX standpoint, right? So you can, if you have like a very simple UI that allow you to transfer from chain A to chain B, you can just call this function, call this method on the SDK, and then returns an address, and then you just deposit that amount from the user wallet directly into that address, and you relax because the Axelar layer picks it up on your behalf and then process it through the Axelar network and make sure it gets routed to the destination chain. And in this example, it's Rahat, wallet. So this is one of the ways you could do token transfers with Axelar. Another one is the send token method, right? The first one I talked about is doing it from the SDK, like from the front end, right? Using
So
JS
before
SDK.
we move here, there's an interesting question that came up here.
Yeah.
Maybe it would be good to clarify. Um,
Okay.
does this mean that dexes are not needed? I think it's referring
Um,
to like sending ETH or transferring tokens.
yes, of course, DEXs are needed, right? Because you need to cater for like liquidity, have like amount liquidity that is available for that particular asset that you want to do. So if you want to do things around, swapping content, that's well, of course, there are liquidity available for those assets that you want to, swap or do things like that within those DEXs. So this is just for you to send assets directly. So if you want to start dealing with like swap from one asset to the other, then you should think about, decentralized exchange.
Cool. Thank you.
How that answers your question? Yeah. So the next one here is the token transfer, the send token. So the first one I talked about was, doing things from JS side of things like JavaScript SDK directly interacting on the front end. But what if you want to do it on the smart contract, right? Send token is a function on the Axelar gateway for EVM contract, right? That facilitates, token transfer between EVM and Cosmos chains. So what does this mean? And then how is this different from the first one? So this is a method that you can directly call on your smart contract. So you are not doing something on the front end, you're doing directly on the smart contract. Maybe you have your contract with a lot of code, custom features and all of that. And then you want to be able to send assets from one protocol to the other from your, contract directly. Then you can just import the Axelar Solidity SDK, and then you call the send token method and specify the destination chain, the destination address, the asset symbol, and also the amount that you want to, send across chain, right? So This is what you need to specify when you want to call this method um, directly from your smart contract. Now, moving on, which is the third, the last one in this category of token transfer, is the interchain tokens, right? Interchain tokens allow you to send token cross-chain, build your own asset bridges, build asset transfer into your interchain decentralized application, and many other use cases that you could center around interchain tokens. Right? So should in case you have your token on chain A and you want to have a bridgeable version on chain B, chain C, chain D, like about 16 plus blockchain as it's currently supported by Axelar, then all you just need to do is to go to the portal or do it programmatically, and you'll be able to configure, you'll be able to like register that your token as a canonical interchain token that is going to be bridgeable across all of these, networks. So how is this different from deposit addresses and also send token? The cool part is you get to create a standardized ERC20 token on multiple chain via the portal. So even though you don't have any coding experience, you can just, visit the portal and you'll be able to do all of these things from the UI. Either you have like an existing token or you want to create a brand new interchain token from scratch, be able to do it directly from the portal. Another one is that you can also build a custom token on every chain with built-in method for transfers, right? You can have custom functionality that you get to build into your token and also preserve that, custom functionality across all the other chains that is deployed up. And then finally, and then sorry, not finally, right? We still have like one more point here. So you can also upgrade an existing token by deploying a wrapper on every chain. I think I mentioned this already, where if you have your existing token on chain A, you can deploy a wrapper on other chains and you'll be able to bridge that asset from one network to the other, maintaining total supply across all the chains, right? You can either do it programmatically or you do it directly from the portal that we already have. And then the last one here is, make interchain token executable alongside GMP for enhanced functionality. So this is what the portal looks like. I mentioned the portal like a couple of times. You can also scan this QR code. It takes you directly to the portal on mainnet, right? And then when you land on mainnet, if you want to test it on the testnet, you see this small pop-up here that shows go to testnet, and then you can just go to testnet. So for mainnet is interchain.axelar.dev. For testnet is testnet.interchain.axelar.dev. Excuse me. All right, so here you see a UI that looks exactly like this, where you can connect your wallet. So for existing token, you can just paste in your address. The system will identify the network, and then I'll tell you what to do next by showing you a pop-up for you to register that token as an interchain token. But if you don't have if you don't have existing token and you just want to build your token from scratch, directly from the portal, you just need to connect your wallet. Once you connect your wallet, this button automatically changes to uh, create a new interchain token. Like you say, create a new interchain token. And when you click on it, ask for the token details, the name, the symbol, the amount, the total supply. If it's going to be mintable later on, ask all of this information and then help you deploy your token without, any technical support, or like you don't need to have any prior technical experience to do this directly from the portal. So that's it for like token transfers. So now let's talk about GMP. I mentioned like general message passing like multiple times. Let's talk about what exactly general message passing is, and then how Axelar is using it to send messages, like handle message, from one protocol to the other. So there are two categories here. It's called the core contract and then the core contract with token. So core contract, I will explain what this is. So these are the two general message passing method that we currently have that you can use or call directly from your decentralized application to facilitate sending message from one blockchain to the other. So the first one is core contract, right? What core contract allow you to do is to send message from one protocol to the other. So maybe I'm on, Ethereum, I want to send hello world to Rahat. I want to send hello world to Rahat on maybe Polygon. I can just, call this method. I'll specify the destination chain, in this case is Polygon, and then the contract address. Sorry. And then the contract address. and also the payload. So the payload here is something you should take note of, right? The payload here could be a string, could be a JSON, an array, like any type that you want to encode here. So if I want to send hello world to Rahat on Polygon, then it means that I would just encode hello world here, and then on the destination chain, this payload will be decoded, and then Rahat will be able to see it on the receiving end. So all I just need to do is to specify destination chain contract address and then the payload. And that's it. I can be able to send message from chain A to chain B. And then the second option is called contract with token, right? The function here is called call contract with token. Here, what I'm doing differently is that I'm not just sending message, right? I'm also sending assets alongside the message, right? Or alongside whatsoever that was encoded in the payload. So I'm specifying destination chain here. I'm specifying the contract address. I'm specifying the payload, which is similar to like, call contract. And then I'm specifying the symbol of the asset that I want to send and also the amount of the assets. So once this is triggered here, so the call contract with token is what you call on the source chain. And then the underscore execute with token is what gets run automatically on the destination chain. Like you don't need to like call this, you just need to have it on your contract. On the destination chain, it gets called automatically. And then the you can also encode, you can add any other functionality that you want to happen. Immediately, this function gets called on the destination chain inside this function, and then it gets run automatically on the destination chain. So those are the two things that you can leverage with core contracts. So leverage the general message passing, which is core contract, and also core contract with token. So now let me show you how these things looks like, right? Now that like try to picture like what happens, how the message get processed from like the source chain to the destination chain. So here, an example here is from the source chain, which is Ethereum. You send a message, you trigger the core contract, and then send a message from Ethereum, which is triggered from the decentralized application. It goes directly to the gateway for that particular network, and then it emits an event to the Axelar network where validity and voting happens after this this call have been validated, and then confirmed validity is confirmed on the network. It get routed to the destination chain gateway where approved call contract call is triggered to confirm that this call has been approved by the network, and then goes to the destination chain where the user underscore execute function will get run automatically on the receiving end. So this is what it looks like if I want to send assets. Maybe if I want to send message with core contract from the source chain to the destination chain, or I want to send message with asset, which is core contract with token. The same process happening, like from the source chain, goes through the gateway, goes through the Axelar network, the gateway of the destination chain, and then the underscore execute method, like the destination chain. So let me pause here a little bit. Like, do we have any questions, or can I proceed? Perhaps.
Yeah, no questions so far. I think we're good to go now.
Yeah. All right. So now you've seen like how these things happen from like the source chain to destination chain. So let's look at, okay, now let's dive into the demo session. So this demo, you can scan this QR code and it takes you to a GitHub repository where you have like access to the entire code, and then you can clone and then play around with it. So, but what we're doing in this tutorial, in this demo, is we'll clone that same project, and then we'll look at the smart contract. We'll deploy the smart contract on blockchain, right? And then we'll connect the smart contract to front end, and we'll test the application together. So let me switch over to my browser where I already have like the end results, what the end results looks like. So let me refresh this to be sure we have everything fresh. So right now, if you clone the project, let me just stop it. So if you clone the project, right, this is what you're going to see. You see this, this UI that shows, um, this is a decentralized application built to send bounty across different networks. So say for example, I want to do a giveaway. I want to send a bounty to like 4 addresses. I can just specify the amount here, approve the amount, and then specify the addresses I want to receive that particular asset on any network, right? And I will just click send, and then it goes through Axelar, get validated, and also the funds get disbursed to all of the addresses. So a very good example is, let me just connect my wallet back. So I'm on Phantom Testnet right now, and then this is an example that I already did here, where I get to send. I sent 10 AUSDC from Phantom, and I sent it to like different network on different chains, right? So I specified 2 different address in this example. It can be 2, 3, 4, 5, 6, 7, in fact 1,000, depending on the amount that you want to spend, you want to send, and also the share ratio that you want them to get, right? So the total address here is 2. You can see the recipient, you can see the amount received for each recipient. So all of these details here is pulled from the contract. So you get to see everything happening on chain, right, as they happen. So this is the end result. This is what it looks like. But then let's switch over to the code and then quickly go through what we have. So if you clone the project, right, this is what you are going to see. You see let me zoom in a little bit. Yeah. So you see a very simple UI. You see this folder that contains the Rahat project, and also we have the pages, right? Under the pages, you go to index.js. That's where we have like the front end code happening. But then for the contracts, we have, if you go into the Rahat folder, we have contracts, we have bounty.sol, where we have the bounty executable contract. So let's quickly go through this and then see what it looks like, right? So,
So really quick, we
okay,
did have a question come in.
all right.
Do we need to call the execute function on the destination chain before we receive the message?
No, you don't need to. In fact, you don't need to do anything on the destination chain. What you just need to do is you deploy your contract on both chains, or like any chains that you want to, interact with, right? After deploying it there, once you send message from your source chain to the destination chain, underscore execute method gets automatically picked up by the Axelar executable, and then it gets run automatically by the Axelar executable. So you don't need to do anything on the source chain. Just make sure that you have that underscore execute method on that contract on both chains, like both source chain and the destination chain. So in this case, it could be deploying to like 3 different chains, right? So just make sure you have your contract deployed on all of these chains, and then you can trigger the core contract method from the chain A, that's the source chain, to any of these chain that you want to send message to. And then from there, the underscore execute method get runs automatically. How that answers the question.
Nice.
Yeah, so this is what the contract looks like. If you clone the project, you of course see all of these things there. But then let's quickly go through what is happening in this contract. So one thing we did first was to import the interface that we need from the Axelar Network SDK, right? So let me minimize this and do this. So yeah, we are importing the Axelar executable and also the Axelar gateway. You see all of these things, where we are using them, and also the gas service. So one thing that is very important about the gas service is, of course, if you want to send, I mentioned like you can send from chain A to chain B or whatever chain, and it goes through Axelar. If you want to send from chain A to chain B, and it's going through Axelar, we have 3 blockchains here in question, right? We have the chain A, the first blockchain, we have the Axelar network, and then we have the chain B, which is the destination chain. So in chain A, you have to pay gas, right? Chain B, you have to pay gas. Chain B here is the Axelar network because it's a blockchain too. And then chain C, you have to pay gas. So, but what the gas service help you to do here is it allows you to pay once in your native currency. So if you're sending from Ethereum to Avalanche, you pay in the native currency, which is it on Ethereum, right? And then that's all you need to cover the end-to-end transaction from sending message or sending assets from Ethereum to any of this network through Axelar. So you don't need to pay like 3 times, you just pay once, and then Axelar handles like the process to make sure that the message gets executed, get confirmed, on the network, and then executed on the destination chain. All right, so that's why we are importing all of this. And then the gateway, the executable is where we have like the underscore executable, method that we'll be using. And also the gateway is where we get to call the core contract method directly within our contracts. So yeah, we created a very simple contract here, and inside the contract we have the gas service, where we just create like a variable to track, to get the gas service so that we can use it here, which is of course inherited from the interface that we imported. And also we also created like these state variables, right? The reason why we're creating this state variable is if we go back to this front end, right? You can see I was able to track the total amount and then the number of addresses here because I want everything to happen on chain, verifiable, and all of that. So that's why I'm creating this state variable here to keep track of the amount that was received and then the bounty recipient, the number of like the address of the recipient um, that was that is valid or like that was meant to receive this particular bounty on the chains that we want to send to. So we are keeping track of both, the amounts received and also the recipients. And then moving on, we have the constructor here, where we get to set up the contract by initializing the Axelar gateway service, Axelar gateway, and also the gas service. So you might be wondering what exactly does this mean, right? So I mentioned during the presentation that we have like gateways deployed for different, ecosystem, and the same thing for gas service, right? So that is why we are specifying this in the constructor. So where can you find this gateway and the gas service? You can find that directly on our documentation. It's very, 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 very easy. So if you go to docs.axelar.dev, let me go to the beginning. This is what you see when you go to docs.axelar.dev, and then you just click on developer, and then you scroll down, click on contract address, and then click on testnet. That's for testnet, right? Let me zoom in a little bit just to show you guys can see my screen. So this is for testnet. You see that we have all of these EVM contract addresses here for every chain that we currently support, right? So this is where you can get to the gateway. So for Phantom, for example, you can see the gateway here and also the gas service receiver. So when you are deploying that contract, you need to specify this gateway and the gas service receiver in the constructor, right? So let me go back to the code, right? This is what we are specifying, and then we are assigning that to the gas service variable that we defined earlier on here. So now that's it for like the constructor. What we need to do next is to create a function that will allow us to send tokens to multiple addresses on different blockchain. And then we are creating a very simple function here called the send to many. And what exactly is the send to many function doing? The send to many function allow us to, of course, send to different tokens, right? It takes in the destination chain, it takes in the destination address, it takes in the destination addresses, and also the symbol of the asset you want to send, and then the amount. These are all the things that we are passing on the front end. Don't worry, when we get to the front end code, you see all of these things that we are specifying when we wanted to interact with this contract. And then because gas payment is required, we're making sure that anyone calling this function already like has a sufficient amount that is required for gas payment, right? So that is why we have this require method here. And then what we are doing first is to get the token address from the gateway. So, these are tokens that we support on the gateway. So you are using the symbol to get the exact token address that you want to send from, chain A to chain B. And then what we are doing next is to transfer that's amount to this contract address. And then after that, we approve the gateway, which is a contract, to spend the amount that we specify initially that we want to send. So these are the things we are doing here, and then we proceed to pay native gas. But before we pay native gas, see what we are doing here on line 47. We are encoding the destination chain addresses in a payload, right? So why are we doing this, right? We want to send bounty to different addresses, right? And then this is coming from the user, like you specify on the front end and specify all these addresses. So we are getting all of these addresses, right, that was specified when you call this function, which is destination addresses. And then we are encoding all of this address in a payload. And after doing that, we now need to pay native gas. Like the example, the explanation I gave earlier on like the gas you need to pay for sales chain, Axelar network, and also the destination chain. So this is where we are using the gas service to call the pay native gas for call contract with token. And then we are specifying, like, of course, the message value that was passed in. And we are specifying the address here, which is this address. We're specifying the destination chain, destination address, the payload, this payload that we encoded that contains the destination addresses, and then the symbol, the amount, and the message of sender. So this message of sender is important here because this message of sender is a sender address that you need to specify. Say, for example, you want to send assets or message from Ethereum to Polygon, right? And then the gas payment that you make, it's around maybe 0.01. And then at the end of the transaction, at the end of the end-to-end execution, the gas that was utilized was less than 0.01. That means you have some leftovers, right? That leftovers will be refunded automatically to the address that you specify here. So there's nothing like maybe you pay higher than the expected gas, right? Even if you pay higher for some reason, although we always encourage you utilize our SDK to get the gas estimation on the front end. So that would give you like an estimated amount that is required for this transaction, so that you don't get to pay like a lot more, even though you still get refunded. But in the first place, you don't get to pay a lot more, right? So that refund automatically goes to any address specified here. So in this case, I'm specifying the message of sender, right? So the refund automatically goes back to the message of sender, person that initiated this call. And then finally, after paying gas, after we make sure that, okay, gas is paid and we are sure that everything is good to go, we call the call contracts with token method, and then we also specify the destination chain. This is where we are doing the actual, call to send these assets from the chain A to chain B. Now, that's it for what we need for send to many. This is all we need to, send to many. And then I created additional functions here to get all the recipients so that we can be able to display them here in our front end here. So I can display it here. So we get all this just returns like the recipients array. And then these are just additional method. And finally, the last one, which is the underscore execute method. It's an internal function, right? That get override to execute token transfer upon the cross-chain call on the destination chain, right? You can see it takes in, like, you can specify the source chain and the source address, but I didn't specify that. I just left that here. But I also want to point it out that in case you want to keep track of where the message is coming from, you can just specify that, and then you'll be able to track that here. And also the payload that was sent from the destination, from the source chain, the token symbol, and the amounts, right? So what are we doing on that? So when this underscore execute with token method get called automatically, what are we doing after that? Here, we are decoding the payload. Remember, the payload contains our addresses, and these are the addresses that we want to send assets to. So we are decoding that payload to get the address, and we are also making sure that we get access to the token address by checking the gateway, using the token symbol to search for the token address on the gateway. And then once we have the token address, what we just need to do is to set the amount that was received, and then also the recipient that was decoded from the payload. And then finally, we are distributing the amount that was sent equally to these addresses, right? You can write whatsoever logic that you want to. Maybe you want one particular account to get way more than you can do all of these things here. But in this case, we are just splitting equal amounts to all the recipients, and then we are distributing it. So what we are basically doing is for each recipient, we are transferring this sent amount here after we already divide the amount by the total length. So if you have 10 and then we have 5 recipients, it means that 2 USDC to each recipient, because we have 10 USDC, right? So that's what we are doing here, and then we are just doing the token transfer to the recipient, and that's all you need to send message from one protocol to the other alongside any assets that you want to send. So now that we have this, you've already seen the end result, but let me go through the process of deploying this contract so you see how it looks like. So now I have this script here, which is called the deploy contract script. Of course, this I had a project was specifying the contract, and then we're specifying the guest service and the guest the gateway and the guest service. So I'll be deploying to Phantom in this example, but don't forget that I've already set up, like in the project, you see the setup for the hard hat configuration here, where we already set up the RPC for Phantom and Mumbai, which is the network that I want to test with right now. Of course, you can test with any network. Axelar is connected to 60 plus chain, so you can test it whatsoever network that you want to test it. And then I've also, my environment variable is also set. I have my private key set up already. And so now let's go back to the deploy.js file. Because we want to deploy to Phantom, we'll go to our documentation, make sure we copy the contract, the gateway contract on Phantom, paste it in, and then we copy the gas service also, gas service contract, and then paste it in. So now we can head over to our browser, to our terminal. Let me zoom in a little bit. Yeah, so you should be able to see my screen right now, clear? So now, this is my terminal. I believe you guys can see my screen. Let me just do
Would you be able to bump it up a little bit?
Yep. Yes.
I think that's good.
How about now?
Yeah.
Yeah, cool. Yeah, so I'm already inside the Protocol Explorer demo with Axelar project. And then what I want to do here is to make sure I see the into Rahat. Because now what we want to do is to run, is to deploy our contract. So what do we need to deploy our contract? We can just run the command npx add hat. So we want to run script inside the script folder slash I think it's called deploy.js, and then we want to specify the network. In this case is Phantom. So this is what we specified here. So don't forget, like the name you specify. Let me go back to the hard hat. Name I specified here, Phantom. That is why I'm calling that network there. So now that we have this, so we can run the script. So we should see the contract address deploy. Oh, I think let me confirm the name of the folder, the script or scripts. Oh, scripts, yeah. So go and then go back. Yeah, so scripts, then click deploy. So now we're waiting for it to deploy on Phantom. So after you deploy, let's just wait for it to deploy, then we get the contract address. So now we have the contract address. We can just quickly confirm this is successful by just going to testnet.ftm scan. .ftm scan, which is the testnet for Phantom, and I just paste it in and search for it to be sure that everything goes. So you can see it's what 27 seconds ago. We are sure that everything went well. It has been deployed successfully. So now that's it. That's what we need for Phantom. Let's do the same, but then don't forget to copy the contract address. It's very, very important because we'll be using it on the front end to interact with the contract. So now let me copy that and then just save it here. Deploy.js. Let me just save it here. So this is what Phantom, and then I can just save it. So I'll drop it here, and then we'll do the same thing for Polygon, right? Let's go back here and then scroll down. You see Polygon. So let's copy the gateway contract address and then add it in the constructor, and also the guest service, right? So now that we have this, we can just go back to our terminal and then use the same command, but in this case now, we'll specify Mumbai. I think Mumbai was what we specified inside our config here. Check the config here, Mumbai, right? So now we have Mumbai. We can deploy to Mumbai. And then we just wait a few seconds for it to confirm, for it to deploy successfully on Mumbai network. And then we can just make sure that everything is fine. So we don't assume went well. Confirm on the Mumbai testnet and then click on it. So we have it 14 seconds ago. So we are now good to go with the contract deployment. Let's make sure we copy this and we go back to the deploy script so that we can just save it for later use. Yeah, so we have this, right? So now we've successfully deployed the contract on both chains that we'll be testing with in this workshop. So now that's it. That's all we need. That's all we need to do inside the hard directory. So now let's go back to the front end UI. This contains like tons of UI codes. If you're already familiar with React, you should just be glancing through. But if you're not, you should just like follow along to understand some of the things we're able to do. It's just like some UI manipulation to approve, execute, and also how we are making the contract call. So before we do that, before I forget, let's go to the env on the front end. Yeah, this is the env on the front end, and then this is where we have the contract address here, the Phantom contract address, and also the Polygon contract address. So and also the RPC. So while we are using the RPC, we want to read from the destination chain because our destination chain is what is Polygon in this case. So we are reading from the destination. After we send the message from Phantom in this example to Polygon, we want to make sure that it has successfully been confirmed or received on the destination chain. So let me quickly add our contract address inside. Yeah, I think we saved it inside deploy.js. So let me add it to our environment variable. I just replaced with this one. That was the one I used to test initially for everyone to see what's going to happen like end to end after we deploy this decentralized application. So now we have this setup. Let me just close this. And then we can see we have all of this set up already. So let's go back to our application. First, you should see that, let me refresh this. Yeah, you can see, let me just wait for a second to be sure it doesn't read. Yeah, you can see it shows like waiting for response, right? Because we haven't interacted with the contract address. We just deployed it newly. We have not sent anything or interacted with it. That's why you see waiting for response, right? So now let's go back to the front end code to quickly see time. Yeah, the front end code, we have the index.js, like everything is written inside the index.js file. So once you go through it, you'll be able to, follow along. So what we're just basically doing here, importing the contract address on Polygon, the contract address on Phantom, on Polygon, and also the RPC URL. We are reading all of these things from the variable, from the environment variable. And then when you scroll down, we are also setting like a bunch of state variables to keep track of things. And another thing I want to point out here is the Axelar SDK that we are using. So remember during the presentation, I think I talked about, doing an estimation that is going to be sufficient for that cross-chain call, right? So this is where you can leverage the Axelar SDK. Just calling it, you'll be able to get the estimated gas fee, and then you'll be able to use that gas fee to facilitate that constraint call and be sure that it's going to be enough for the end-to-end execution, right? So yeah, this is what we did here. We're also setting like a bunch of state variables here. These are just like state variables to keep track of, the amount, the button visibility, to make sure that we approve before we try to send, and all of those things. And then we are using the toast notification here to keep track. So this is where we are actually making the approval call. So because it's USDC, of course, you need to approve the contract address to be able to spend that amount. So what we are doing first here is, if you're familiar with WAGMI already, we are using this use contract right, use contract right hook from WAGMI, and then we're just specifying the address that we want to do the approval from. This approval is very important for you to approve the contract to spend, because now we're dealing with ERC20, right? So we are also passing the ABI, and then we are specifying the function name, which is approve, and the arguments, we are passing the contract address and the amount that we want to approve. So take a note, we are passing the amounts that we get from the front end. We are not hard putting anything here, right? Any amount you specify on the front end will be approved. And then after approval, we are also making sure that we kind of wait for the transaction to be successful, so that we can keep track of is USDC success, just the success status. And this is also just to double check. Again, we are checking allowance. You can decide not to do this, right? But it's always cool to keep track, just to make sure that the approval is successful before you try to, send the amount, so that it doesn't run into an error, right? So what we are doing here is like this, typically the same thing. We are just calling a different method here, which is what the allowance, to be sure that allowance is successful. And then, of course, back to our gas estimator, we are calling the gas estimator API, the gas estimate function on our API, and then we are specifying the source chain, the destination chain, the currency, in this case FTN, right? And then the optional, the gas limit, and then the multiplier. So these are like defaults or like optional parameters that you can pass. And then we are setting this value return into the state variables that we created earlier, which is the what? Gas fee, right? So moving on, we are done with like approval. We now want to do the actual sending. So we are also using the same hook. Yeah.
So we're kind of running out of time.
Yeah.
Cool.
Yeah. So yeah, we're running out of time. That's why I'm like pretty fast. Yes, I just want to quickly like rush through like the front end, and then we'll see the end results immediately. So right now we have like all of this UI, like this call, which is similar thing, and then we are passing the address, the amounts, the assets that we want to send. And we're also just doing some sort of validation to make sure that the amount enter, the address enter is correct. And then we're calling the method. So all of these things are just like double checking. On the front end, we're reading the destination chain here, and we're calling the gas estimator, tracking if it's successful. We send the toast notification. If it's not, we log an error. And that's everything we are doing here. So every other thing you're seeing here are just like UI changes. The main thing are the function call that we're able to call to interact with the contract. So that's what it looks like. So now let's go back to our application and then just refresh. Let me see what's going on here. Bundle. Okay, let me see. Did our application crash? Let's just do the final test real quick. Don't have time. Okay, yeah, let me go back to the application and then save for you to refresh. Oh yeah, so now I'm connected here, so I can quickly do a test since this is a new contract. So let's say 20 USDC. I'm connected to Phantom, so I'll need to just approve. We see this approval, and then we should see a MetaMask confirmation. We next approve, and then approve. Just wait for you to be confirmed. It says USDC approved successfully. So now you can see like we have the address to specify. We have the input field to specify the addresses that we want to send to. So while we have that, we can just specify the address. And let me just pick one more address here. real quick. So we use accounts. Yep. So here, and then I can specify that here now, and then I can click on send. So now this is going to send bounty to two different addresses on different chains, right? Um, let's just wait for it. Sending bounty and then send bounty what? Sent successfully. So we can, let's just confirm this actually happened. So this is the last transaction. Let's copy the transaction. And the cool part, you can head over to like testnet.axelarscan.io. This is an explorer that allow you to view how things move from chain A to chain B. So I'll paste in the address here, the transaction hash here. Let's just wait for it to load. Yeah, so this is the transaction hash that we're waiting for. Let's just wait a second. This is going to auto refresh itself. You can see I didn't click anything. It refreshed, confirmed that gas was paid, confirmed on the network, and now it's approving. You can see the details of the transaction here and the function that gets called, which is called contract token, 20 AUSDC from Phantom through Axelar to Polygon. And yeah, let's just wait. This should not take too long to confirm. And you can also see some other very useful information about how everything moves on chain. You can also click to view all of these things on chain. Confirmed. Let's just wait. This should be approved in 3 seconds so that we can see what it looks like on the UI. Yeah, it has been approved. And then finally, let's wait for execution to happen on the destination chain. So this is where that execution, that underscore execute with token I was talking about, gets run automatically on the destination chain. So now it has been executed successfully. So let's go back to our application and then just wait. Boom. You can see we have what? 28 USDC sent, 2 addresses, and then the amount received on different address. And that's as simple and cool as it is, right? So it doesn't matter where this address is wants to receive this amount, but they should be rest assured that 20 USDC was sent and then they received 10 AUSDC each. So this is for the example for just using 2 addresses, right? So yeah, that's what the demo looks like. Let me quickly go back to the presentation and then wrap up because we don't have time. Yeah, so now we've been able to like successfully, go through the project, like clone the project, look at the smart contract and also deploy the smart contract together and connect our smart contract with the front-end UI that we have and test the application successfully. So now one cool thing we also try to help builders that are building is to create like example snippets for you as a builder to take a look at, right? If you Google Axelar example, you see this repository where you could find example on core contract with token, a lot of examples on even ITS, right? You can take a look at it and then play around with things yourself. In fact, you can also, the cool part is you don't have to test on testnet, you can do this locally on your local network, right? You can do it locally on your laptop. You can test, play around with it, send assets, send messages, send all of these things. And then for Foundry guys, we also, have a Foundry Axelar GMP example that you can look at. The first one I showed previously was, with Rahat. If you want to try things with Foundry, you can try it out. And also it gives you the ability to test on testnet or locally. So you can do all of this question interaction locally also.
Nice.
So what next? What next? We have a dedicated repository for support in case you want to, you have questions, you have clarifications, we can open a new issue here. We get notification instantly. So we'll be able to jump on it and quickly answer your questions. You just go to github.com/axelarnetwork/support repository. You find like issues created already and already responded to. So you can create yours and then we'll get notification. We'll be happy to help you. And then finally, thank you all for joining. My name is Idris Oluisi. Once again, you can reach out to me at idris@interruplabs.io. And you can also scan this QR code, right? And let me know. It takes this literally less than 1 minute. It's a survey of 1 minute. And then just let me know what you think about this workshop, how you have, how you find this workshop helpful or not. Like, let me know. I'll be happy, to get all of this feedback. Thank you very much, Rahat, for having me.
Yeah, man. Thanks so much for being a part of this, bro. It was awesome
Yeah.
having you on the stream. Thank you all for tuning in. If you do have further questions, drop them on Twitter. On the replies, we'll be sure to get them answered, or head over to that link that Idris had mentioned there. So, really
Yeah.
cool stuff here, man. Thank you again.
Yeah. Thank you all for having me. Bye for now.
Cool.